Hey class, let's look at the very last page of our test. This image was not on the last page of the test, but I just wanted to show you this because it's kind of silly that because of time constraints, we look at very tiny data sets. And I just want to kind of just push this home, getting a small data set and saying that, oh, it looks like a line fits through it, that could be completely irrelevant, right? Because maybe you just randomly picked 3 points or 4 points or 5 points that just made it look like that. But maybe if you looked at a bigger data set, something else would be happening. So this is an image of a pretty large data set, probably 200, 300 data points. And we can see that, yeah, there's something going on here, right? It looks very clear the more I look at this that as my X values are getting larger, right, as X values increase, it looks pretty clear that the Y values also increase. So this is increasing, X's get larger. As X's get larger, Y gets larger. Correlation coefficient's clearly positive. Maybe it's like R is like 0.9, but you get the idea. So we also have this idea of residuals. Every single data point in this set, right, is not exactly what the model predicted. Well, I mean, with some exceptions, right? It looks like this data point right here, it looks like this data point has no residual because there's no difference between the actual Y value and the predicted Y value, right? The difference between those is nothing. So anytime a data point lives on the line, its residual is nothing. But if we were to consider let me grab this ruler, go 90 degrees, come over here, so right around here, I'm just going to point out this one. So it looks like when X is, over a little bit, it looks like when X is 2, looks like when X is the number 2, it gets pretty close to, get back up here, pretty close to Y being, Y being somewhere between 3 and 4. I don't know what that is exactly. But you can see when X is 2, right down here, when X is about 2, we can see that here's Y is 2, here's Y is 3.5. Maybe we'll call this like 3 point, we'll call this 3.6. We'll say 3.6. Okay, so that's that data point. I'll write it down. 2 comma 3.6. When X is 2, Y is 3.6. Well, the residual for that data point is the difference between where that data point actually was and where the model predicted it would be. So this yellow dot right here represents the predicted value of Y. Why is it predicted? Because when I plug in this value of X, right, the equation says I should be getting about this amount, about 2 for Y, right? If I put in X is 2, it's saying Y should be about 2. Okay, but it's not, right? When I put in X is 2, I'm not getting Y is 2. The actual value was 3.6. So if I look at that, this yellow dot, my predicted value of Y is the number 2. And up here for X, my actual value of Y, right? The actual value of Y was 3.6. So what's the residual? Again, it's the residual is equal to the difference between those. It's the difference between the actual Y value and the predicted Y value. If I take my actual Y value, which was 3.6, and I minus what the model predicted 2, I get 1.6. Notice it is positive, right? 3.6 minus 2 is positive 1.6. The length of this line segment is exactly 1.6. So that's the idea of residual. This association, there's an association between these two variables. It looks linear. It looks like it's increasing. I'd say it's a strong association. And all these data points, are not predicted perfectly, but there is a difference, and that's called the residual. All right, so that's just a way of review. Let's go ahead and look at the actual test questions. So the first question said, hey, find the LSRL for the data listed below. Round the slope and y-intercept to 2 decimal places. Okay, to 2 decimal places. So in order to do this, of course, we are going to use our TI calculators. This is the virtual one that behaves just like the ones that we use in class, and we'll go ahead and use that for this problem. So in order to enter the data, of course, we press the data button. And once here, we're going to go ahead and enter our X values, 0.79, enter, or the down arrow. And then I got 2.65 down arrow, or enter. Then I got 3, enter, and then 4.2, enter. So you can see those values. I'm going to go over now and enter the corresponding y values. So my first y should be 4.67, enter. And then I should be entering 6.7 for the next y. And 3 should be getting 10, and 4.2 should be getting 11.16, enter. All right, so there we go. Our data is entered. Now let's do our regression. So to do that, I'm going to press the button stats, or second rather, to get to stats. Stats is one of the green buttons here. So it's second, same button as data, but I'm getting the stats here. This is a 2-variable situation because we had both x's and y's. I press enter, and I'm going to go enter, enter, and then calc. And there's a lot of things here that it tells me about the data, but if I go all the way down to D, E, and F, these are the 3 that we care about. So on line on line D, it tells me that A is equal to 1.97. 1.97. Now that value is my slope rounded to 2 decimal places. Below that, on line E, it tells me that B is equal to 2.89. That value is my y-intercept rounded to 2 decimal places. So the equation of my line of best fit is y is equal to 1.97 times x plus 2.89. Now, one of the things I could do, and I think I do it in a question below, I don't do it actually at this point, but one of the things we should be able to do is if I said, hey, what is the residual for this particular data point? What's this point's residual? Well, I remind myself that the residual is equal to the actual y value minus the predicted y value. And I can see my actual y value is the number 10. So I'd say residual equals 10 minus. Now, what's my predicted value, right? So in order to figure out the predicted y value, what I've got to do is take the number 3 and plug it into the equation right there. So I'm going to go ahead and do that calculation. I'll clear my calculator. I'm going to say 1.9. Oh no, let me get rid of you. Second, quit. I'm going to say 1.97 times 3 and then plus 2.89 and press enter. And it says 8.8. So when I plug 3 into the equation, this model predicts, it makes a predicted value of y. It says y should be 8.8. So here's my predicted y. It's 8.8. I know the actual y. So my residual is going to be 10 minus 8.8. And if I take 10 and I subtract this number, 10 minus that number, I get, right, 1.2. So the residual, right, 1.2. So the residual for this point, right, the residual for this point is 1.2. And it's positive, right? So the model is predicting something lower, right? Because the actual value is higher. So it's actual minus predicted. All right, just wanted to talk about that. Move on. Move on. It's just like flexibility here. Next question. Get rid of this calculator. It says, hey, 4 data plots are pointed and their LSRL is shown at right. Okay. Which points have positive residuals? Are you kidding me? This was a soft ball, right? And there's nothing wrong with, and actually softballs hurt. I've been hit by them multiple times. The residuals, the points that have positive residuals are both C and D. And which points have negative residuals? Well, that would be A has a negative residual, as does B. Next question. It says 4 data points are plotted at right. The LSRL and the equation of the LSRL are also shown. Point D is located at 414. What is the residual of point D? Okay. So here's what I know. So for point D, the actual y value is the number 14. Got it. It is. The actual y is 14. The predicted y I'm going to find. And how do I find the predicted y? I'm going to take this value of x. and I'm going to plug it into my equation, right? So I'm going to plug it into that equation. The actual value of x is 4, and I'm going to plug it into that. So let me grab the calculator again. Hello, calculator. Clear this. So I'm going to go 1.54. That's not working. Try that again. Nope. 1.54 times the number 4 plus 6.46. And when I press enter, it says 12.62. Okay, it does. It says 12.62. So I'm going to come over here and record that my predicted y value is 12.62. So what's the residual for point D? It's going to be the actual value minus the predicted value. It's going to be 14 minus 12.62. If I take 14, and then I'm going to subtract the value above. I went up arrow, grab it, subtract it. I get 1.38. So the residual for point D is 1.38. Notice it's positive. Kind of nice to notice that, yeah, D is above the data, right? So this little tiny line right here, the line between the predicted value and the actual value, the length of that is positive 1.38. That's all we got. That was the test. The test for chapter 4 that you completed in groups. We'll be taking a test next week when we come back on Tuesday. I hope you have a great vacation. Enjoy the 9 days with your family. And I look forward to seeing you back in class, well rested and ready to continue.